Before we dive into the video, here is a quick note from today's sponsor. This video is sponsored by my favorite technology store, Micro Center. Micro Center is one of the largest consumer electronics retailers in the United States. It is tech heaven. I've been shopping at Micro Center for 5 years now. It's absolutely my favorite place because they just have so much cool gear and equipment. Micro Center has over 30,000 products in stock, and there is something for everyone. Whether or not you just casually use technology for getting your work done, or if you are a power user or a system administrator or a programmer or a graphics designer or animator or anything, Micro Center has something for you. When I was going to build my custom PC, I went to Micro Center and told them, hey, I need parts that give me enough horsepower to be able to run a ton of virtual machines and do security research. And they immediately had something offhand they could recommend to me and show me other options, and it was just an awesome experience. Whether or not you're shopping in person at a physical store or if you're browsing products online, Micro Center offers the selection, service, and sales expertise that is just top-notch. They tailor your experience to the best that it can be based off of exhaustive studies on customer shopping, customer surveys, and extensive testing. This really sets Micro Center apart from the rest. And hey, if you're a new customer for Micro Center, they have a free 128 gigabyte USB flash drive and a 128 gigabyte micro SD card available for you. This is new customers only, no purchase necessary, limited time offer valid in store only, limit one per customer. You know the drill. So check them out. Click my link in the description below to claim a free 128 gigabyte flash drive and micro SD card and go enjoy Micro Center. Huge thanks to Micro Center for sponsoring this video. In this video, we are diving into more of PicoCTF 2022. This is the second video, and hopefully many that I'll be able to go ahead and record and get out. In the last video, we did a basic binary exploitation challenge that was, hey, just keeping track of, input sanitization of whether or not we're actually entering a number or something that isn't a number. If you haven't seen that video, go check it out. It's really how we get the story started for PicoCTF 2022. With that said, let's dive into what we're doing now. All right, so I'm over here on my computer screen. I am inside my Kali Linux virtual machine. I have the PicoCTF game opened up, and we're moving on to this next challenge over here right beside the one we just completed. This is in the cryptography category, and it's called basic-mod1. Okay, it says, we found this weird message being passed around on the servers, and we think we have a working decryption scheme. Typo for decryption. Download the message here. We can go ahead and click that download link. Take each number mod 37 and map it to the following character set. 0 to 25 is the alphabet in uppercase, 26 to 35 are decimal digits, and 36 is an underscore. Wrap your decrypted message in the PicoCTF flag format, also known as PicoCTF with curly braces, and then your decrypted message. Okay, so let's go ahead and grab this link to download this, and I'll hop back over to my terminal. Let me clean up some of my mess from the previous videos, and now let's get back to where we were in our terminal. I'll go ahead and actually move and make this basic file exploit, the one that we just completed previously. I'm actually going to use a neat trick where I will use the curly braces and a comma here to denote that this is completed. That's basically the same thing as me supplying the second argument here with the destination. It just goes ahead and actually makes that change sort of in line, if you consider it that way. Now we can move back out of this directory, and let's make a new directory for that other category that we're going to work into called cryptography. Good. Let's make a directory for this called mod1. That is the name of this challenge, or I suppose basic-mod1. So we'll call that. Move in here, and then again, we'll use that wget command to be able to download this from the internet. Here we go. And now, hitting ls to list stuff in this current directory, I have that message.txt. I'm going to go ahead and open that up yet again in my text editor, Sublime Text. And this is what we are working with. So we have values here, 54, 396, 131, 198, etc., 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 etc. Okay, so if our instructions given the challenge prompt are to take each number mod 37 and map it to the following character set, then we could probably do some silly stuff. Truthfully, I will end up going ahead and scripting this out. Now, I am a fan of the scripting language Python, I'll admit. It's easy to read, easy to write, it's a hacker's language, and that it's very easy to just rapidly prototype stuff and get a proof of concept out. I probably write god-awful garbage code, but I can get some stuff done in that. So bear with me, I will get us working in Python in this video. So what I'm going to end up doing is going back to my terminal, and you could work with Python in an interactive mode. In fact, we should be using Python 3 in this case. Python 2 is a previous version, but it was deprecated in 2020, and you should not be using Python 2 anymore, ever. If you are, stop it, please, and let's use Python 3. Again, you could do this in an interactive mode, in which case I could, hey, I'm at this prompt here of Python, and I could print as input after I see this prompt of 3 arrows, and passing inside the parentheses for this print function, I could just say something like, hey, please subscribe. Totally misspelling please yet again. If you watched the previous video, you probably saw me do that a bit. And then if we wanted to exit out of this, we could use exit as a function just like that. Now, let's go ahead and create like a tinker.py script. I'm using .py as the file extension to denote this is a Python script. Now, I really like to use a shebang line, not super necessary in case you are just going to pass it to the interpreter, like Python, and give it a file to run, but it's good to do just in case some people don't do that. The shebang line syntax is an octothorpe, the hashtag, right, the pound symbol, with an exclamation point and then a path to the program that's going to end up executing the script. I'm using env as the environment rendition of, hey, where is Python 3 stored on this box? Whatever host it may happen to run on if this code is ever transferred to someone else's machine. That's just, again, good practice. So what we could do is we could actually open a file. We could use the open function to do that, and we'll give it the file name as a string. String denoted with these double quotes around the word there. And the way we do this, while this function might return a file handle, we want to be able to work with that file handle. In Python, you could do this with what they call context managers, and that's using a with statement preceding it, but then calling it an object with an as keyword following it. As can kind of give us a variable name or an object name, how we want to refer to this, and I'll use FILP for like file pointer, for file handle, or whatever. And in Python, rather than using kind of the curly braces that you saw in C, when we were looking at that previous video, you're using a colon to be able to denote, hey, this is a new code block or new branch of logic that I'm going to work in. So with that said, we now could work with this FILP file pointer variable and handle an object inside of this context manager. This will automatically close it for us, so we don't have to run, hey, that FILP.close. Being inside of this with statement and using indentation to denote, hey, that's where we are now, that'll do that for us. It just saves us some dirty work and makes sure, hey, the program is actually cleaning up after its mess. Anyway, we have a file pointer and we want to read the contents out of it. So we'll take that object and do a .read. Super simple, super easy. And what we'll end up doing that is calling it maybe a variable. I'll just call it contents, nice and easy. And then we could go ahead and print out the contents, what we were able to read from that file. Yeah? Now, if I run this, I hit I just hit Control B on my keyboard, and I'm actually going to move that into another tab. In Sublime Text, I hit Shift Alt 2, and that let me split it up in a little bit. So now on my right-hand side, you can see the contents of me running the script, and on the left-hand side, you can see the code if I make any changes to it, hitting Control B to run every single time. So with that, we know that we now have the contents, but if we want to parse through every single number, they're all separated by spaces. So we could split this up. We'll do contents.split. And that will give us now a list, kind of denoted by those square braces here. This list is something that we could work through. But if we want to consider all of these as real numbers, as integer values rather than strings, you can see the single quotes, apostrophes surrounding these, they're all strings at the moment. So we want to be able to cast or convert these types of data into something different, like an integer. And we could do this with like a loop. Here, let's actually set this as a strings as a variable. And now if I were to print out strings, it is the exact same thing here. But you could do something like, hey, for every value in those strings, if you wanted to print out each one, you could print them out just like that. And now you have all these on a new line, because print will automatically add a new line for you. But again, this is still just a string value. You could do something, like casting this to an integer. If I run this, the code doesn't look like it's changed at all, but now we've actually taken a different data type, right? Let me show you that super duper quick. Let's say we took every value and printed out the type of every value as another operator following that. And then let's say we took int value as an integer of every value. And then what if we printed that out just as well? Let's take the int value and we'll say that, okay, that is now the type of our int value passed in. Oh, I broke something. Oh, Python 3 is super duper specific about using indentation and being consistent with tabs versus spaces. You'll notice, hey, I have a tab character here when everything else is spaces. If I highlight it, you can see Sublime Text kind of creating an indicator for that. It's a couple dots versus a long horizontal line. In Sublime Text, you can Control-Shift-P to open the command prompt sort of thing. And if I started to type in like spaces, you can see a couple options that show here. One of these is called convert the indentation to spaces. So I'll hit enter on that, and now the tab is gone. And that could work through all across the file. Super handy, super good to do. I'll hit Control B again to run this. And notice, I'm going to add a couple new lines so this is a little bit more visual for you. Sure, there was our 54 as a string at the top, but then immediately after it, we cast it for every iteration, right, to an integer value. And then the type of that is an integer type, given that class. So that's one way we could do this. That was through a big, long loop, though. I don't know if I want to get into a whole lot of list comprehension in this, but I think it would be good to do so you get to know some of that Python syntactic sugar. What we could do is actually take this strings value that we used to have and do some magic with it. Let's say, we wrap this in square braces, and then this list originally that we had, the splitting on the contents, what if we added like an inline for loop within these square braces? Let's say for val in contents.split. So now we're building out a loop in line, right? Right before this for keyword, we could add kind of a modifier that we want to do for this value. If it's something super simple like casting it to an integer, what we could do, just pass in the value there. So now if I print out numbers, you can see that after we've done that list comprehension technique with some syntactic sugar in Python, run this, all of those quotation marks and apostrophes are gone. These are no longer string values, but they are integers. Voodoo witchcraft magic, I know. But now we could do something interesting, like taking mod 37 and mapping it as needed. Let's do that. What I'm going to end up doing is actually looping now through all of these numbers. Maybe we could very well have done that inside of our for loop, because we're going to end up creating a for loop just as well. Let's say for number in numbers, singular versus plural here, bear with me. Sure, let's print out each number, but then let's mod it, and the syntax or the operator for that in Python is a percent sign. If folks aren't familiar with the mod, that is a modulus. And modulus is the remainder of a division operation. So say we took 54 divided by 37, and that is, or excuse me, was it 37? It was 37. 37, we would see, okay, what that remainder is from that division. So if we took 37 out of 54, it's only going to fit in there one time, right? So let's display that out. Oh, it's 17, 26, 25, et cetera, et cetera, et cetera. Good to know, right? So we have this all mapped out for each of those values now. But we know that each of these need to be mapped to a letter in the alphabet. We know, okay, 0 to 25 is the alphabet in uppercase, 26 to 35 are decimal digits, and 36 is an underscore. So we'll have to grab some special things in Python. Now, the same way that you might have seen in the previous video when we saw an include statement in C, you're pulling in other code to use in your own code, we could do that in Python. We can import like a library or module, and there's one that's called string. It's built into Python, and you actually get access to a whole lot of data sets that are already created, like the alphabet. Sorry, what I've done here, by the way, is I just added the comment, or kind of the octothorpe, that hashtag again. That'll denote a comment for code that isn't executed. Like you could leave notes, right, in your script. It's not going to do anything. And we could just temporarily comment all this out so it's not going to execute. I hit Control / on my keyboard to automatically do that within Sublime Text, and you can toggle that on and off super duper easy. So with that said, we've imported the string module. We could print out some things inside of the string module or library, like ASCII uppercase. And that is a variable denoting the alphabet. That saves us from typing, here's a string value A, B, C, D, E, F, G, H, etc., and totally getting the alphabet wrong. That just saves some legwork for us. It also, because it's something that could be iterated through, like in a loop, it allows us to index values at a specific number. So let's say I was to index this at 0, right? That'll print out the value A. I'm using the square braces to denote the index here that I want to retrieve. 1 will be B, 2 will be C, etc. Now you might be thinking, hey, why aren't we starting 1 as A? Why does it start at 0? Computers are weird, like to count at 0. You know the drill. So with string ASCII uppercase, we have the alphabet, and we also have string ASCII, or actually not even ASCII, but just string.digits, and that'll give us the numbers. 0 through 9. So we could use that as a reference, and we know, what was it? It said 36 is an underscore. Super cool. So let's do some things. Now, we have this loop that prints out the modulus for us, and let's actually capture that as a variable. Let's say modulus can equal that value, rather than printing it out. Now, we could actually check if modulus is in a range. We said, 0 to 255. Range is actually going to be inclusive at the beginning, 0 in our case, up to the number that we put in here. So if I were to say 25, it'll actually only count up to 24. So we have to go just one more, 26, right? Keeping it 0 based, as you know. So if the modulus is in that range, what we could do is we could print out, how about modulus being our index for something like string ASCII uppercase. With that, we take the number 17 and we grab that position inside of our alphabet. Super cool, right? So let me run that. Ooh, so I see a couple capital letters here. It's not printing out all the other moduluses though. Let's add an else statement. So if this condition isn't met, we'll do something else instead. Let's print out the modulus so we see where our gaps are. These are the things that we still need to track, right? So let's do what they call in Python an elif. It's like adding another condition inside of a condition that you already have going in that if statement. So we know, okay, if the modulus is in the range of, what did they say, 26 to 35? We only said 26 as a start here, or an end, but you could have very well supplied a number to begin with, like a min or a max, to create the range that you want to extrapolate in Python. So with that said, we could totally just take 26 as the real start value, again, inclusive at the beginning, not at the end, and we could go up to 36. As we knew, 36 is the underscore. So let's check if that modulus is in that range. We could go ahead and actually print out it as an index for our digits. the numbers that we were able to retrieve just previously. Now let's go ahead and view all this. Oh, and I broke something. See what's happening here? I got an error because there is a string index out of range. Modulus right now is the number 27 or 28 or whatever, and digits are only 0 through 9 in the set that they have. If you were to count each individual instance, you only have 10 numbers, not 26. So we'll have to subtract out kind of an offset to bring us back to the baseline of the index that we could count from in those numbers. Does that make sense? Weird thing, right? But I could probably show you if need be. Let's actually take... I'm trying to think quick on my feet. How could I visualize that for you? You know what? Bear with me. Let's take the modulus and let's subtract out what we know is the baseline start from that, because it has to kind of continue from 0, not starting all the way over at 26. How about that? Cool. Now we got some shenanigans, but we're still missing 36 as our last special case. If that's just an underscore, we know that that's going to end up getting caught in our else statement, our last sort of condition here. We could go ahead and print out just an underscore. Interesting. We have this all displayed here, but it's all vertical because there's a new line after every iteration. So let's modify this just a little bit, and let's add an end keyword argument to our print function. We could display this out, and that gives us, rather than ending the string with a new line, let's actually end it with an empty string so we don't print a new line. Print by default will include the new line character and bring it down. Let's add this just as well here. And now, if I hit Control B to run this script, we see round and round and some hexadecimal digits for us. Some value that may be specific to us. With that said, we're building out the flag. So I'm going to do something weird, and I'm actually going to keep track of these characters for our flag inside of a list, or an empty list, right? Just square braces, doing this all before we loop through the message file. And I'm going to take everything that we were just printing out beforehand. We don't need the end anymore because we just want the value. We aren't going to end up printing this, but let's append it to this flag sort of container, or this list that we're building out as we loop through it. I'll do flag.append and just pass this in inside the parentheses. Super cool, super easy. Do that again here and again here. And now if I run this, we don't get any output, right? Because I'm not printing anything. But after all is said and done, outside of our with statement, we could go ahead and print out, if I could type, print out that flag. Now this is all as a list, right? Multiple values, but we want to put it all together. We have all the puzzle pieces now. Let's join them all together. You can do this in Python with a join function. That actually uses a base as like a base string to be able to use as the delimiter, as the delimiter to join these all together. So in our case, we just want to cram all the characters though. We don't need a delimiter. We can just use an empty string and .join to bring that all together. Does that make sense? Now we print out round and round. Super easy, super cool. But we know, we want PicoCTF in there, right? So let's actually include, I'll do something special called an F string in Python, where I take regular quotation marks to denote, hey, I'm using a string value, but I add an F in front of it. And that allows me to include some other code or variable expansion inside of the string. So here, I'll put PicoCTF, and I'll use curly braces as they know the PicoCTF string wants. But oddly enough, Python inside of an F string is going to expect like a variable or some code inside of curly braces. If you need to use curly braces inside of an F string, you just put more curly braces there. So I know it looks weird. Hey, there's a double, but that way it'll print out a literal set of curly braces. Now, inside of those curly braces, we'll use our own curly braces to fill in this variable here. Maybe that's super duper confusing. Let me show you that in a couple different ways. Oh, in fact, I'm probably already breaking something. F string expecting a extra curly brace. No, you have one, my friend. Maybe it's not going to like using F strings. That's okay. We could do this in a couple different ways. We could do something like a %s without using that F preceding our double quotes to notice a string. %s will take like a format specifier. And following that string value, the S stands for, hey, we'll give it another string. We could just pass in what this all returns here, following the %sign. How about that? Better, right? Or maybe you could just kind of concatenate stuff together, adding strings, ending what we would have had inside with our join together flag value. Just using a plus sign to put the puzzle pieces together, you'll get the exact same result. But different ways you might be able to go about it. Different ways to skin a cat, you know? So, with that, we have our solution. We have the flag, and we are done. Did we do some cryptography here? It's up to you. We did a heck of a lot of Python, maybe learn some new tricks. I don't know if you're familiar with these or not. I'm trying to be fundamental. I'm trying to be basic. I'm trying to be helping out the new folks in this. But I hope there was something enjoyable, and maybe you learned some new gimmicks, whether it's list comprehension or using the quick range here. We probably could have done that in a better way, but I hope this all makes sense. I hope there was some good learning lessons and nuggets in there for you. Let's grab this flag, and let's go ahead and submit it. Call that done, and boom, hey, we've earned another 100 points, and we are cruising right along. So, hey, thank you so much, everybody. I hope you had fun. Seriously, I hope you enjoyed some of this. I know these are long-winded, probably more so than they need to be for something as fundamental as this, but I hope there's some good teachings that come from it. Thank you so much for watching, everybody. If you did like this video, please do those YouTube algorithm things. You know, it really helps the channel grow. Like, comment, subscribe, share things around. Anything. I'm super grateful. Thank you, thank you, thank you. I'll see you in the next video. Take care. With